Oh, I can write. Yay, okay, this might work. Good news. Okay, so I don't have to write tablet style and have bad handwriting. As long as it goes past 2 minutes, it should work. Okay. Last time we learned chain rule, right? Okay, so that was a little complicated, but we got through, especially at the end. We did that triple chain. Ooh, that was fun. D dx of f of g of x. This is just a quick reminder what we did last time. What's the chain rule? F prime of
G of x times G of x.
Okay, so every time you do a chain rule problem, I would recommend writing that down every time, so that you've written it so many times you have it memorized. You can write it in your sleep. So you go, oh, chain rule. I would write this out before you even start applying the chain rule every time. So you've written it a million times and you have it memorized. Same with our next two rules today, because I don't have like a fun little song or funny phrase to help you memorize them. Okay, I even struggle over remembering these ones because I don't have a nice little shortcut. That's too small, so I'm going to rewrite it. Today we're doing derivatives of logs and exponential functions. Okay, so the derivative, and actually this is not even a log function, but it's an a to the u. If you notice all of these problems from 1 through 6, what's the base in all of the problems 1 through 6? Is it an x? No. It's like it's a constant, right? A or 2, e, 5, e, those are all constants. Where's the x? In the exponent. Okay, so that's what u is. U is the function with the x. Because it might not just be an x. This one has cosine of 2x plus 1. Okay, so the derivative of something with a base that's not an x raised to a power with an x is the same thing, a to the u times natural log a times u prime. Oh, almost missed the prime. That could have been bad. Okay, so same thing times natural log of the base times derivative of the exponent. So same natural log of the base, derivative of the exponent. Okay, so if we are going to d dx, number 1, we have to do it to both sides, so it doesn't become an expression. The left-hand side has to be, we're taking the derivative of y with respect to which variable? X. Okay, so the variable on top is the variable you're taking the derivative of with respect to x. Okay, so here, derivative of 2 to the x is a numerical base raised to a function with a variable, right? So it's going to be the same thing, 2 to the x, times natural log of the base, so the base was 2, times the derivative of u prime, or the derivative of the exponent. What's the derivative of the exponent? Just 1, right? So we don't really have to write a 1. We could just write 2 to the x natural log 2, and that would be the derivative. Does that make sense? Okay, number 2. Still recording. I think we're on making good progress with that. Okay, number 2. dy dx, because we ddx both sides. dy dx, derivative of y with respect to x equals, what would come first? To the 4x plus 2 times natural log of the base times 4, because that's the derivative of the exponent. Okay, so we have then dy dx equals, can we simplify that at all? Not really, because this base 5 has a bunch of mumbo jumbo up in the top. So oftentimes though we like to see that in front, right, because it's the coefficient. 4 times 5, all I would really do is maybe just rearrange it, putting the 4 in front. Okay? I want you to go through and try 3 and 4. One sec. Let me just make sure. Yep. I've actually told you before what the derivative of. Yep. Yep. When we looked at the graphs and graphing derivatives based off of the graph, we actually already did number 4. Good. So number 3, what are you guys getting for number 3?
7 to
dy dx equals what?
7
To the?
minus 2x cubed.
Times natural log of the base times the derivative. What's the derivative of pi? 0, because that's a constant. Minus 2x cubed. What's the derivative of that? Squared. Yep. So make sure you have parentheses or bring that in front so it doesn't look like minus. Okay, this one's a good one. So dy dx on number 4 equals the original times natural log of the base times the derivative of x. What's the derivative of x? 1. What is natural log e? It's also 1. So dy dx equals e to the x times 1, which is just e to the x. Remember we did that with graphs. E to the x derivative is itself. All right, number 5. Work with your partner on that one. Probably want a partner. You think you have it? Stand up. They can come check. You got it? Good job. If you have to versus do you want to? I think both those answers are the same. Oh, wait. Yeah, that doesn't work. Okay, some of those answers are different. You know you want to do the downside. You don't want to do it. Yeah, this one has the chain rule, right?
Oh, it does.
It pops out on you. So you have to be careful, especially if you trig function with something inside of it. That should spark chain rule. So when you take the derivative of cosine 2x plus 1, it is chain. Okay, who else has figured it out with the chain rule? Man, Anna. She was like done 5 minutes ago.
Okay, I have
Question?
I just like to remind you up front of that. Or should I just like listen to that?
Unless you can't leave.
Is this?
Yeah. And then you'll be done. Yep. Okay, who has the chain rule for the derivative of cosine of 2x plus 1?
-2.
Christine? Sorry.
negative sine of
Can't write. Negative sine of
2x plus 1 times 2.
times 2. Good. So it's the derivative of cosine, which is negative sine, of the g function times by the derivative of the g function. Okay, what is, again, natural log e? Yeah, don't leave that. Dy dx equals 1, so that cancels out. I might write the negative 2 sine of 2x plus 1 in front times e to the cosine 2x plus 1. Any questions about the chain rule? Because that was the new one that we did last time. Okay, one more. Actually, 2 more. 6 and 7.
You can scoot over and look at this one.
No, it's okay.
Chris isn't here.
Normal rule.
What's the derivative of the constant? This one is equals dy. I just gotta find that. Okay, now we do number 7.
Good. Who's done with both and wants to go write number 6 on the board? Okay.
I'll do 7. Do we have to do it out?
5?
We just gotta work on 7 for
No, wait, 5 is a constant. So it's 5 greater than constant times limit 5 times 0. So that's just 0. This equals 0.
Well, you're gonna have to take the derivative of all of that, but the derivative of 1 turns to 0. This is another chain, which x squared is the outer function. Okay, let's see what Christine has up there. Oh, she's rearranging. She's really nice handwriting. Okay, box that up. Do you agree with that? Did everyone get that?
Yep.
Great. Okay, Kennedy, go do number 7,
Do
please.
I have to do it out, or can I just like write the answer?
Well, as long as it's an equation as an answer.
Okay.
I have really bad handwriting with this, so I apologize. I actually have bad handwriting.
Excellent. Why is number 7 just 0?
Because it's timesing by 0 when you do the last part and you take the derivative of the exponent.
True, because when you do the derivative of e plus 1, it's 0. Did you really have to go through the whole process, though?
I guess not.
No, because everything on the right side is a number. The whole right side is a constant, and the derivative of any constant is 0. 5 is a constant, e is a constant, 1 is a constant. So you can go through the whole thing and prove it's 0, or if you realize all of that was a constant, the derivative is just 0. So, sneaky one. Okay, next. Logarithms. Couple things to remember about logs. Log base x, or not base x, log of x has what base if it's not written? Log base 10. Log base 10 of x. Also, the natural log of x is log base e. Log base e of x. So 2 things to remember about logs. Okay, so this is too small, so I'm going to rewrite it. If we're taking the derivative of a log base, what is that, an a, of u. Here's the derivative rule. It's 1 divided by the part, u is the part, times natural log, or 1 over natural log of the base, times u prime. That's our rule. So log base a of u is the part, equals 1 divided by the part times 1 over natural log of the base times the derivative of the part. That's just one you gotta just do flashcard a million times and remember, or write it down a million times. So every time you see one of these problems, or even the exponentials, I'd write out the formula so that you always remember it. You've written it a million times, so it's ingrained in your head. Okay, so let's try number 8. Some brown. Okay, if we take the derivative, we're going to get dy dx. Don't forget to write that. Okay, a is what in number 8? A is 5, that's the base. U is that quadratic binomial, right? So we use 1 over the part, which is the quadratic, 2x squared plus 4x, times what? 1 over natural log 5, which is the base. 1 over natural log of the base, times the derivative of the part. What's the part's derivative?
4x plus 4.
Good, and you need to put that in parentheses, because everything's going to be times. If you need to stand up, you need to stand up and stay awake. Okay? And, yeah, we can stop there. Okay? So, go try 9, go try 10 together with your neighbor. This one is not. So you need to remember how this formula is in terms of log, not in terms of natural log. So you need to change natural log in terms of log.
Yeah.
Which is 1, but you forgot about this.
Oh, sorry, I meant to.
Yeah,
I
that's
thought
right.
that in my head, I'm sorry.
Wait, so what is number 10?
It's just 1 over 2.
Oh.
I just completely spaced to put the T part.
Oh.
So I just put 1 over 2.
Okay, go ahead and start doing 11 and 12. You have volunteer, go write number 9 up. Who wants to write 9? Okay, son. And you continue with 9 or 11 and 12.
Look at my slippers, my slippers. My flip-flop,
You
my
know, that
slippers.
should be the natural log of E.
Oh.
Because the log base. No, it is natural log of E. Because you changed it to,
Yeah, exactly. What am I doing
yeah,
with
because you
that?
changed it to the log base E
I feel like
of T. So 1 over T times 1 over natural log of the base, which is log E, which natural log E is what? 1. So this whole fraction is just 1. And then times by the derivative of T. So times by 1. Yes, rewrite it, which is that. Okay, let's see what Un put up. Thumbs up, thumbs down. Do you agree with Un for number 9?
Yeah.
Thumbs up, thumbs down. Good, I agree. Who wants to go write number 10? Number 10 is slightly tricky. Anna? Yep, Anna, go write number 10. What color do you like, Anna?
Red.
Red. Okay, let's make sure it's skinny for you. Okay. What are we doing over here?
Oh, the 13th, what am I doing?
Yep, that's all right. I'll just simplify it.
Oh, they're constant then, like. They're constant.
Oh, you haven't done 12 yet? Okay, good. Do 12. Okay, let's look at what Anna has. Anna, can you stay up there for just a second? Explain what was the first step you have to do on number 10 in order to apply the rule we have.
You have to change it to log.
Change what to log?
You have to change the len to log because the rule is log.
Yeah, you have to change natural log into terms of log base e because the rule is logs, not natural log. Great, and then you end up having that 1 over natural log e, right? And don't ever leave that. What is natural log e? 1, so it cancels out. So that's perfect. 1 over t times 1 is just 1 over t, is what dy dx is. Actually, in this case, I lied. This case is not dy dx, is it? What were we taking derivative of? dy dt. So yeah, I don't think we've really seen any of those yet. So just grab another color and just go over. You can just push the button down at the bottom or at the top, and just change your x there to a t. dy dt, because that's the variable we're taking the derivative of. So watch out for that too. Okay, who wants to come do the work for number 11? Jasmine, thank you. You can all do 12. It's the first rule we learned of derivatives is number 12.
Do you have to use a log as well? You don't have to use a log.
No, it doesn't have a log in it, does it?
Boom.
What's the first rule we learned in derivatives?
Why is it under logarithmic function?
Because the AP test isn't going to be all nice and pretty and be like, okay, this page is derivatives with power rule. This page is derivatives with chain
Can I
rule.
give up a
No, it's going to mix them. You have to be prepared.
It's very tough.
I didn't know that.
I might not
With what?
Number 12.
How you make
Well, on your
this?
paper.
How you make
Skinny?
this? Yeah.
Okay, right there, 3 lines. And then, oh, it looks like you're already on the skinny. Okay. Yeah, it looks thick. Yeah, now it's skinny. Okay.
Alright. It looks like a deal.
What
Okay,
was
just
the
don't touch my hand.
the square root?
I'm not right.
But do you have to get rid of this?
Right.
So then you Alright, I got 12.
Okay, you need to rethink this one. Remember the power
Just
rule.
like in front. Set in front, maybe subtract 1.
I don't think because there's a
I don't think this exponent's right. Oh, actually, yes, because you already did that. Okay. Yep. That's good.
It's great.
Except for erase that y. You have 2 y's.
It's great.
Okay, let's look at Jasmine's number 11. Agree or disagree?
Well, she put the 6a on the top of it.
Yeah, but is it still equivalent?
Yeah.
Yeah. So you can keep them separate like that, or you can just put the 6a on top over that. But it's the same, so that's great. Thanks, Jasmine. Okay, who thinks that they figured out 12? You've already been up. Alex?
B.
Alex, what color do you want?
Green.
Green, like army green,
Bright
cute
Camel
green.
Actually, cute green, yeah.
Cute green, okay, you get cute green.
It's an ugly green. It's a gloomy green.
X. Oh, my. Okay.
The color? Yeah, it's like cute color. mucus, as long as you have healthy mucus, is like more lime green.
Oh. Anatomy.
Okay, so step to the side and then explain to us what you had to do.
I just used the power rule then. So I just put the 1 plus root 2 in front. And I subtracted 1 from the exponent.
Because it was 1 plus root 2, subtract 1. So the 1's cancel, leaving only root 2. Great, Alex, good job. Any questions about the power rule? It's kind of an obscure power rule. But 1 plus root 2, subtract 1.
It just makes you kind of think because there's a square root in there.
Okay, how are you feeling? It looks like everyone's doing really good on the exponent, exponential, and logarithmic derivatives. Okay, what's different? What's different about number 13?
It's differentiation. Oh.
X to the x. So where is the x? Both the base and the exponent. So think back in secondary 3 when you solved equations with an x in the exponent. How did you get the x out of the exponent? You took the log. Okay? So the same thing applies here. So essentially, I don't want that color, let's do purple. Essentially, the first step is, and this, I'll put a note, this is when the variable is in the base and, that's a D, and the exponent. It's in both positions. To get it out of the exponent so that you don't have it in 2 positions, step 1 is we're actually going to natural log both sides. Natural log both sides. Okay, so let me erase this first. Okay, natural log both sides. So I get natural log y equals natural log x to the x. How does natural logging or even logging both sides help us get the x out of the exponent? What can we do with the exponent now? Front. That's the power rule, right? We can bring it as a multiplier in front. So we now have natural log y equals x times natural log x.
That is sandwich.
Oh, it's a natural log sandwich, yep, with x spread. Okay, so our whole goal here was to find dy dx. What do you think we could do next to find dy dx? We took care about the exponent issue.
Change it to log. No, that's mine. Hurry up.
What is dy dx?
This is a good question.
What is dy dx? It's a derivative. So, can we now take the derivative? Can we take the derivative of something that looks like this?
Yes.
Can I take this derivative of this? What rule is this? How many functions are right here? It's not chain. It's not a function in a function. It's product rule. We have a linear function times a natural log function. That's product rule. So next step, dy dx both sides. Okay? So our formulas we have above are in forms of log, not natural log. So really quick, let's do d dx, oops, not dy dx, d dx both sides. D dx, not natural log y, but can I do log base e of y? Yes. And d dx, x times the log base e of x. Can we do that? And in the process of doing this, you're going to discover what the derivative of a natural log of y is. Okay? So keep going with that. Take the derivative. Okay, let's just do the first step, the next step, and then stop. So make sure everyone's on the same page. So do your derivative on the left, do your derivative on the y, and then stop. Okay, who has the derivative on the left side? What is it? 1 over the part times natural log e times the derivative of y, which is just 1. Ooh, this is a 1, this is a 1. So the derivative, oh, that's a y. The derivative of natural log y is what? 1 over y. That's something you should start memorizing. d dx of natural log y is 1 over y. Well, yeah. And then d dx natural log x would be 1 over x. Yeah. Okay, we'll talk about partials later. Okay, now the derivative of this, product rule. What's the same for product rule? First d last plus last d first. And actually, I lied on this. That's what I paused for a minute. This is actually 1 over y d dx. It still has the d dx because we didn't take the derivative with respect to y. We took the derivative with respect to x. So this still needs, we'll do a lot more of this when we get into like partials, but this still needs d dx. And we took the derivative of y with what did I do wrong? dy dx. This is 1 over y. I should still have a dy dx in there. Because when we took the derivative of y, and everything's with respect to x. So whenever you're taking the derivative of y, you should always have a dy dx. When you take the derivative of x, it's just dx dx. But what is dx dx? 1. That's why we don't write it. Whenever you take a derivative of y, you get a dy dx because you're taking the derivative of y with respect to x. Okay, so even though it wasn't just a 1 dy dx, we got 1 over y, we have to attach the dy dx, and that's like an easy thing to forget. We don't generally do it when we're taking a derivative of x with respect to x because it's just a 1. And that's just kind of redundant putting dx dx over everything. So this needs to say dy dx times that derivative, which is 1 over y. And then what's our product rule saying? First d last plus last d first. So first is x. What's the derivative of natural log x? 1 over x. We just showed that with derivative of natural log y. 1 over x. First d last plus last, and you can go back to the natural log if you want, or you can put log base e. Last d first. What's the derivative of the first? 1. Okay? This is the only place that a dy dx popped out, and the question was to solve for dy dx. If we don't write this, then we have no dy dx's at all, and we can't solve for dy dx. Does that make sense? If you take the derivative of a y, you have to write dy dx. So let's find dy dx. First, it looks like I'm going to simplify the right-hand side. What happens to x times 1 over x?
1.
1. So this whole side is 1 plus natural log x. So how do we find dy dx? Times by y over 1, or just y. Times by y, those will cancel out, but we have times everything by y. Now here's a problem, an easy thing to forget to do. This cannot be your answer. The final step, so step 3, what we just did, we solve for dy dx. The final step is to replace y. We know the value of y. What's the value of y? The original function. X to the x power. So step 4 is plug in what y equals. So don't leave y in your equation. This should be all in terms of x, and that's something super easy to forget. Okay? So that y at the very beginning was originally written as x to the x power, so you just replace it with x to the x power. Okay, let's do one more, number 14. And we'll do a quick derivative quiz, because all your derivatives now are fresh. None of the ones from today are on derivatives. I wasn't that mean. Okay, what do we first have to do when we have an x in the base and an x in the exponent? Natural log both sides. Okay, natural log y, natural log x to the natural log x. That allows us to take the exponent and put it where? In front with the power rule. So we now have natural log y equals natural log x times natural log x. That's nice. Okay. Then what did we do? d dx, both sides. That means take the derivative of both sides. So we're going to d dx this. We're going to d dx this. Is there another way to write natural log x times natural log x?
Times 2?
Isn't natural log x squared? It's 2 natural log x. No. All squared. I think we can do all squared. So it depends if you want to do product rule or if you want to do chain rule, because the all squared would be chain rule. So what do you want to do? Do you want to keep it in product rule or do you want it in chain rule?
What's the
I would say product rule.
I like chain.
You do chain rule, see if you get the same
Wait,
thing.
so
We're going to
wait.
do product rule.
But wouldn't it be dy dx?
No. After we take the derivative, you get a dy dx. But we haven't taken the derivative yet. We're just saying we're going to take the derivative.
Alright.
So d dx of natural log y. What's the derivative of natural log y with respect to x? 1 over y, but we took it to y, so it has to be 1 over y
dy dx.
dy dx. Otherwise, we never have a dy dx in the problem. Okay? Now, the derivative of natural log x times natural log x. Firsty last plus lasty first. Firsty last, what's the derivative of natural log x? 1 over x. Technically dx dx, but dx dx is redundant. Plus last, natural log x, d first. What's the derivative of the first? 1 over x. So now that we're adding, we have 2 of those, right? 2 natural log x's times, actually, can I just say 2 over x, natural log x?
For what?
Because this is not part of the natural log, it's being times. So I have 2 over x natural log x. Is that legal?
Don't even know.
Because these are exactly the same. These are like terms, yes? And there's 2 of them. But this 1 over x is not inside of the natural log. It's timesing. So there's 2 of them. So can I put 2 over x, natural log x? And how do you now solve for dy dx?
Now you.
Times by y. Times by y. However, don't leave y in your answer. dy dx equals. Y was originally x to the natural log x. I'm going to put it in my fraction. There's a 2 in the numerator also. There's an x in the denominator. Natural log x.
Wow, that's rough.
Okay. Okay. So, any questions before we go to our derivative test that doesn't have derivatives on logs and e's? That's nice.
Wait, I have a question.
Mm-hmm.
On number 11 on the last note.
Number 11.
Yes, on last class's note.
Oh,
Oh.
let me bring that up then. Chain rule notes.
I think 11's what I'm thinking.
Okay, bring in out your 4.1 notes. Calculus. There you are.
I don't have one like 7.
Why is it 4.4?
Where, because it works better doing it in an alternate order than how the book is. Okay, what number did you say?
Number 11.
Could we also look at
Would
14?
f of x be sine of x to the 1/2, or would it be just sine of x and then g of x
Sine of x is f of x, and then g of x
would be 5x minus 1
to the 1/2, yeah. So f of x is sine of x, g of x is 5x minus 1 to the 1/2 power, because the square root is the 1/2 power. Okay, Kennedy?
For 14 then, that has both cosine and sine, would you have to use like product rule for that, or would, like, which one would be the f?
Well, you're gonna have to do a chain on them separately.
Just do two separate chains.
Yeah, so like the first one you could label f of x, but what would your outer function be for a cosine to the negative third?
Would it just be cosine of x?
What's the outer function? That's the hardest one to see.
Or is that x to the
It's a polynomial, x to the negative third. And g of x is the inner function cosine x. But you're going to have to pick different letters because you'll have to do a separate chain on that one. This one, like if I just picked m and n, m, what's the outer function here?
Is that going to be the x or negative?
It'll have to be negative.
Negative x to the fifth.
Negative x to the fifth, and the inner function is sine of x. Okay? And then you continue. Okay, so clear up your desks.
And
I
then
don't
you
think
just
this German
subtract
test
the
is
two
too hard.
once you get it.
What?
Then you would still just subtract the two, or add
Yep.
whatever at the start.
Yep.
Okay.
Yep, and then you subtract them separately. Well, actually, you probably add them because you put the negative right there. Okay, clear up your desks. Just as a reminder, this problem is a good example. Why did we keep this as a x to the negative third when we're taking a derivative? Do we know how to take a derivative? How would we have to take the derivative of this? What's that rule? Quotient rule. That's too much work. Isn't it easier just to do power rule? Okay. Okay, and whatever time remains after this, we will answer questions on 4.1 homework. I actually would like you to go find a seat that's not next to someone. So, whoever's kind of in the middle, grab a seat in the back, please.
Bye-bye.
Thank you.
Bye-bye.